Uh, so looks like no one has any audio issues. Perfect. Okay, awesome. So let's get started. In the previous class, we kind of had a overview and introduction of what research is, um, and kind of what it appeals to be, kind of the ideal of it, right? Like we discussed a lot of the theory, we discussed a lot of the methodology that kind of underpins the entire process. Um, so today we're going to be going a little more into the real world. We're going to be talking about how we present the research. We're going to be talking about how we do it, how we kind of condition our minds to go through each of these processes. Um, because, and this is a point again, that I talked about a lot about last time, and I'm going to be talking about a lot this time as well, which is I want to really make clear how this is a process that you guys can do. It's not some mystical thing. It's a very easily explainable thing. The complications of all research is not in the process that you have to follow, but in the questions that come up during the process, if that makes sense. So, but I want to demystify the process at the very least. So first to do that, let's go through some of the assignments that I received. So let me just share this screen. So Lahar, you sent this excellent uh, assessment of Rutherford's plum pudding analysis, and this is exactly what I'm talking about. So the one thing, so you said that he said the question that he was trying to ask is what is the structure of an atom, and so the one thing that I would say is in this theory you switch the prediction and the hypothesis. Uh, so I mean, they're both right. It's just that the hypothesis should be atoms have a nucleus, and the prediction is most of the alpha particles should reflect back from the foil. Because the hypothesis is the initial guess, kind of the initial thought, and then the prediction is what follows from that initial guess. So everything else is perfect. It's just I would reverse the hypothesis and the prediction here. But that's exactly right. This is exactly what I would suggest you guys do. I mean, I only received one assignment, so if the other people in the class could also send them in at some point this week, I find it's really helpful to make sure that you guys kind of have that introduction kind of set in your mind, so we don't have to run into the same questions again and again. So I can make sure that you guys know at least the foundation. So, but this is exactly right, Allahar. Okay. Okay, so back to the normal class. So some of the issues that I usually have with the homework is that I didn't have in this with this session is, but I'll review it regardless because I feel it's helpful. Just to get feedback on this stuff is I had a lot of issues in the past with vagueness and broadness of questions. Um, People have a lot of difficulty kind of coming up with a question, or even when they were analyzing other experiments, coming up with what is the question that they're trying to answer. Because sometimes it's not too obvious, right? And to help with what a lot of students would do is make a very vague, very broad question so that they don't have to, so it's a little easier for them to come up with a guess for it or whatever. So let me just say this right now. A question that is very vague and very broad will be in some ways easier to deal with in the short term, but in the long term, it's going to be very hard to come up with an experiment. It's going to be very hard to come up with a guess. It's going to be very hard to come up with a prediction that follows from a very vague and broad question. So definitely, especially at this point, when you guys are starting off in your research careers, so to say, I would, in the future, pinpoint a question with really precise accuracy. Come up with a question that is, even with the question itself, you have an idea of what the answer is. You have an idea of what the guess is, and it can all kind of just stem naturally from a very specific question. So stay away from vague, broad, general questions. And just clarifying a little bit, also the transition from question to hypothesis to prediction to experiment, using Lahar's assignment as an example. Again, it's the hypothesis is the guess, the prediction is what kind of flows naturally from the guess, what are the physical consequences in the real world if that guess was true, and then the experiment is testing the prediction, right? It's saying, okay, in the Rutherford example, it's saying that if alpha particles are to deflect, then let's actually shoot the alpha particles at the foil and see if it deflects, right? So the experiment is a real world application of the prediction. And yeah, it's funny because I had a note on assignment participation on this slide itself. So obviously this is not a new thing, but I'm not, this is really helpful if you guys will participate and send in the assignments. It's helpful for you guys. So that's all I have to say about that. Okay, Lahar asked, could you just clarify again what the difference between a hypothesis and a prediction is? I'm not sure if you asked that before I clarified, but just to talk a little bit more about that again, the difference is between a guess to a question, the guess of an answer to a question, and the literal physical consequences of that guess. So in your assignments example, I mean, you got it exactly right. It's just reverse the concept of the hypothesis and the prediction. So in your assignment, that the hypothesis, the guess that Rutherford made, like as to the question's answer, what is the structure of an atom? The atoms have a nucleus. So that would be Rutherford's hypothesis, and then his prediction is, okay, what are the physical consequences that would flow from my guess? What must also be true? What's the consequence of that I can test for? And so therefore the prediction would be that most of the alpha particles should reflect. I hope that clarifies. Okay, so now we're going to go back to where we left off in the last class, where we were talking about ethics. And there's two big experiments that I want to talk about today when it comes time to talk about ethics. And these are two experiments that are very commonly brought up in my field, at least, because they're both psychology experiments. And I'm not sure if you guys know, but I'm currently doing my PhD in clinical psychology. So these are very common experiments. And they're also very common because they say something about the human condition, right? The Milgram experiment was done in 1961. It was done by a Yale psychologist, and he sought to test a very controversial question. His question was, could it be that the accomplices to the Holocaust were just following orders, right? You understand that this experiment took place in the context of the Nuremberg trials that were going on, and I think had just recently either ended or was even continuing while Milgram was doing his experiments in the previous years. Um, so if you guys are not familiar with what the Nuremberg trials are, uh, it is a series of trials maybe a decade after the end of World War II that prosecuted several high-ranking Nazi officers. Um, and there were a couple in particular um, where the Nazi officers, their defense was kind of what their, if they had to have a defense, but like um, what they were saying is that, okay, we weren't designing the program that killed all these Jewish people. We were just following the orders. So why should we be blamed as harshly? Um, and there was a lot of pushback on that because there was this idea that, especially among the American people, that that a good, with a good ethical standard, no one would ever follow an order that's as heinous as what they had to do. So Milgram took test to following that kind of idea. And what's interesting here is that, you know, I think people think of research as it can be quite boring. The questions that are being asked are usually, quite obscure. People aren't, but sometimes sometimes the questions you ask are super relevant to the zeitgeist of the time, right? To the era that you're living in. And I think that's when your research will be talked about for a long time. But carrying on, this is the actual article that Milgram published in a newspaper looking for subjects, right? And so, but he cleverly didn't say what he was actually studying. He said that persons were needed for a study of memory. Um, so he didn't want the people participating to know what was actually going on. So this was the experiment, right? There was E, and E is the experimenter, like kind of a scientist in a lab coat. There was T, which is the tester, which is the actual. So T is the subject, and T is the subject that's being studied, and L is an actor. Um, so E and L are both actors. So and L is hooked up to kind of this fake electrical shock machine, and the idea is that the experimenter E is going to ask L a series of memory questions, and L has to respond. And if they get an answer wrong, then the experimenter will ask the tester T to push a button and administer a shock. Of course, what the subject T doesn't know is that E and L are both actors. They don't know that, and L is pretending to receive shocks. Um, and so, and T thinks that, of course, L is being studied when actually they're being studied, right? Um, so, in these series of experiments, each time the actor kind of pretended to get a question wrong, the experimenter would ask the subject T to raise the voltage on the machine. And so throughout the course of the experiment, it was seen that even above 80% I believe the exact figure was 82% of all the subjects that were being tested in this way, um, they agreed to administer a shock with a voltage that would have obviously been lethal um, to the actor if he was actually receiving these shocks. You know, in the paper they talk about the subject, that tester, sobbing because they can hear the screams on the other side of the screen. Screams, of course, that are being acted out, but they still continue to push the button each time. And I think what Milgram was kind of trying to show here, or trying to test was that even if people like anybody from any culture would follow these kind of or these kind of orders, especially coming from a figure of authority, someone who's wearing a lab coat, someone who seems to know what they're doing. Um, so I think this is an interesting experiment, but in the ethics portion of this is that an experiment like this would never take place today for a number of reasons. One, the primary one probably being that there's a lot of trauma being pushed onto the tester, to the subject here. You know, there's people, the subjects talked later about experiencing even PTSD, right, of some kind of post-traumatic stress because of this experiment. They talked about having to deal with the fact that that they were hearing screams, and so all this. Today we would never do something like this because we're trying to limit the trauma and the pain that patients experience. Um, so so for better or for worse, an experiment like this would never be done today. But I still find it very interesting. And just to skim through another kind of version of this experiment, about a decade later, it was a Stanford prison experiment. So I believe 12 subjects were collected, just normal students from Stanford campus, and they were divided into prisoners and guards at the start of the experiment in this basement of a building. And the guards were given uniforms and sunglasses, and the prisoners were given, just shabby smocks, and they were told to kind of act out this kind of role playing scene where the half of the students are prisoners and they're being kept in the basement for a certain period of time, and the other half are guards and they're guarding them. And it quickly descended within days to totally beyond what the leader of the experiment thought that it was going to be. The guards were doing pretty heinous things. They were beating the prisoners. They were at one point they were forcing some of the prisoners to go to the bathroom inside buckets. Like they wouldn't allow them access to toilets. They really kind of dehumanized the prisoners immediately. So again, this is an interesting example of answering a kind of a creative question in a ethically dubious way, because of course, I think within like 3 days, this experiment was shut down just because of how bad things were getting. Again, an experiment like this would never go down today, but it's an interesting question, and it's an interesting way to answer a question like that. Okay, going back to the structure of science and of research. Again, what I wanted to highlight here briefly before we go on is that the hypothesis is something that works for you. You don't work for it. It's a theoretical concept. It's designed to streamline and systematize the practice of research. But there's other ways of doing this. There's something called a null hypothesis, which I'm not going to really go super into today, but it's kind of, so instead of trying to kind of prove that your guess is right, you're more trying to nullify a certain null guess with your test. This is helpful in certain theoretical contexts where it might be hard to prove certain things right, but it might be easier to prove certain things are not right. So again, but there's all these kind of theoretical tools that you guys have. But the point is to use them well and to understand each of them. But for now, let's focus on the standard hypothesis when we're talking in the future. But I kind of want to reiterate again that the hypothesis is not this mystical concept. It's kind of this tool that you guys have. Yeah, so this is kind of an example of what the null hypothesis is. Just the idea that it might be easier to prove that aliens are not to blame and prove that definitively, instead of the alternate hypothesis, right? But again, these are both tools. Okay, so now let's get into kind of the meat of what I wanted to talk about today, which is um, the structure of research and the structure of research presentation specifically. Um, Fortunately or unfortunately, a lot of what research comes down to is the presentation of it. How are people going to receive it? What's the standard way of getting your thoughts best articulated? And this is the standard way. You have the introduction at the beginning, where you're identifying the problem or the question that you're trying to answer, and you're narrowing that question down into a thesis and a hypothesis. So the difference between a question and a thesis is a difference only in vagueness and specificity. The question, when you're articulating it, can be a little more broad, it can be a little more unfocused, but your thesis is just sharp and crystal clear, right? So the difference, so thesis and the question are essentially the same thing. I like to kind of divide those concepts just because it's easier to start with kind of a little bit of a broader question to help me think about what my thesis is from that broader question, kind of crystallize it even further. But you guys can think of the question and the thesis as the same thing, and then the hypothesis kind of flows from that. And so the introduction is where you're introducing those concepts. The methods here is how was the research conducted, and we're going to be talking more about that. And the results, you're summarizing the outcome of the research, whether that's in a chart, in a table, in a graphical way, in a verbal way. You're summarizing the outcome in a way that makes sense for the people who are reading it. And then the analysis, you're evaluating the data that was collected and you're generalizing the findings. And so I believe that we talk later in these slides, but about an interesting concept here is that it's kind of like the shape of what this structure is it resembles an hourglass. So actually, if we go down to so this is the hourglass notion, right? It's kind of you begin with very broad questions, and then in the methods you're narrowing down, in the results you're narrowing down even further. You're talking about very specific things, very specific observations, and then when in the analysis, in the discussion, you're broadening, right? You're generalizing back to questions. You're reaching broad conclusions. So I find that this is a very helpful kind of model to think about when I'm writing a paper, is to begin with broad questions and then narrow down and then broaden back, generalize back. And then of course there's the references where you're listing sources, which is a very important part of the entire process. So let's talk about the introduction. The key thing that the introduction serves to is that it's establishing a context for the research for non-specialists. And every paper should strive for this within reason. Every paper should try to, if you're writing a business paper about the economic surpluses of a city or of a country, then in the introduction you should define your terms. What is an economic surplus? What does GDP stand for? What are the basic fundamental things that you should know about the situation before you dive into the paper? So that's a very important part of the introduction. You're defining your terms. You're kind of talking about key concepts that people might be unaware of that helps understand what the paper is talking about. So that's a big part of it. The other big part of it, of course, is you're articulating your thesis and your hypothesis, and also what is the point of doing this. I think a lot of a lot of students miss this portion of the of when I read papers that students have submitted to me in the past. One thing that's commonly missing from their introduction is talking about um, why is my paper relevant. And if you guys read any paper, and we're going to be actually talking about some of my papers later down the road, but you'll see that it's a very common thing to see in an introduction to see a statement like, for example, nothing like this has been done in the past. Nothing has been studied in this way. No other studies have studied this particular thing in this particular way. So, proving that this is an interesting realm of study is important, and that's also done in the introduction. So now let's talk about the methods. A lot of what we talked previously in the other class about making research systematic, right? Making it different from just searching on Google. So this section is where you're presenting your work as to how you made it systematic. You're presenting the materials, the procedures, the methods that you used in the course of the investigation. And typically this is the easiest section because you should really be taking the notes for the methods all along. This shouldn't be hard to do because you have a very good record of how you did your research as you were doing it, right? So oftentimes this is a short one-page thing that is easy to write, and it's often found in very empirical subjects. Empirical meaning like you're literally doing experiments, because if you guys have ever done lab reports in school, it's very obvious what the method of a physics experiment is. You're kind of just noting down exactly kind of a recipe list of what you did. But in a field like psychology, or in a more qualitative field, it might be harder to figure out what the methods are. Oftentimes they come down to either what the experiment is studying, or if you guys are doing like a review of some kind, and we're going to be talking about that in another class about how to write different kinds of methodologies. But the point here that I want to make clear is that you should be detailing properly what you were doing in the entire course of the research as you were doing it. It makes it very easy to write after. And also, it's very important. This section is very important in terms of kind of the philosophy of science, because part of what's very powerful about science is that people can replicate your work and see if you were right, if you did it the right way. So articulating exactly how you did it helps other people replicate your work. And that's a very big part of science. Okay, here's another very straightforward section. The results. You're just reporting what you found. Oftentimes in my papers, this will be in the form of a chart, of a table. It helps. I've been told a lot that a graphical form of this section really helps people identify relevant details and not get lost in just a jumble of numbers. But again, whatever the results of your experiment is, this is what the section is. And this is I would say that personally, the two hardest sections to write always in a paper is the introduction and the discussion, because both of them are what kind of requires you to be creative and kind of answer questions that are relevant to kind of what your research is really about, right? You're not just a reporter, just reporting what you see and what you did. You're a scientist, right? You're thinking about the consequences, and in the discussion, you're trying to interpret and comment on the data that you got, and so you're generalizing what are the consequences, what are future directions that your research can go. Were you right about the hypothesis? Why were you right? Were you wrong? Why were you wrong? What are some larger problems in this field that this research can help solve? Can you compare this with other research that's being done to see, did other people do it right? And what can you learn, or vice versa? So these are a lot of kind of larger, broader questions that you're trying to answer in a creative way. And yeah, a lot of what separates good research from bad is in this section. And again, I'm going to be sending these slides to you, but this is a very helpful template for the discussion. I find that it helps kind of follow this template of what to talk about. But again, they're the same things as I was saying previously. It's just this is a helpful series of statements to help guide your discussion section. And of course, the references. This is again a key part of research in general, but specifically in the presentation of it. If you guys are studying books, if you guys are studying other papers, if you guys are studying websites, doesn't matter. People have to know what you were studying in order to get the data that you got, and in order to get the information that you got as well. And so it's not just about the experiments itself, but it's also about where are you getting your general information that you put in the introduction? Where are you getting, are you using other forms of, other sources of science in order to come to an understanding of certain topics? Then you should put it in the references. So that's a key part of this process as well. And also making sure that these sources are valid. And these are my sources for this class, to help guide that process. So now let's talk about sample papers. And I thought it would be interesting. In previous classes, I pulled up either other people's papers, certain papers that I've been studying that week or that month. But I thought, in the interest of this class, I thought it'd be cool to look at my own PhD thesis. Let's see. Okay, hopefully you guys see that now. So this 90-page document is, well, the actual thesis itself is about 120 pages, but this is basically the entire last 4 years of my life, last 3 years of my life, which is crazy to think about. Even more, really, when you think about my master's and my undergraduate thesis that led up into this. So this is kind of the culmination of years and years and years of work. And so I thought it would be interesting for you guys to see kind of what primary research looks like at the highest levels of academia. I'm not saying that, this is an amazing, groundbreaking paper, but it is at the very least a very new, very uh, I hope it at least reveals a process of how something like this is done. So my thesis consists of 5 different papers, but they're all around a similar topic, which is psychological well-being in chronic illness. And the specific chronic illness that I'm studying is something called systemic sclerosis. And systemic sclerosis is an autoimmune disorder. We don't have to get into the specifics of it, but it's basically when your body starts to produce too much calcium and deposit that calcium in your joints, sometimes in various organs. So you start to kind of over-calcify from the inside out. You start to lose mobility. You start to develop things like arthritis because you can't move your wrist, you can't move your shoulders as well. You also start to have difficulty digesting food because calcium is being deposited on your GI tract. So we don't have to go into the specifics of it, but it's quite a tough disease to deal with, and but it's also a very rare one. So I find that rare diseases are of course by their very nature understudied. So I thought I would kind of focus in on something like this as opposed to something like cancer, which is very studied, and that goes back to the point of trying to find a gap, right? Trying to find a gap in the research field that's already been studied so that you're not repeating what other people have already done. So because this is quite a rare disease, and also a currently uncurable one, that a lot of people hadn't really looked into this particular context. So I thought that there would be a chance for me to do something new here. So this is the introduction where, as you can see, I'm just literally defining terms, right? What does it mean to have a chronic illness? What is the rates of depression among chronic illness? What is systemic sclerosis, right? Here I define systemic sclerosis for what the disease is, the fact that it has no cure, how many people have it, what's the onset rate of it. I'm talking here about what is the gap of knowledge that I'm trying to fill, the fact that other studies haven't discussed a particular topic. So, all the things that I talked to you guys about what the introduction should have, that's what I tried to put into this. Of course, my introduction is a little longer, a little more complicated. I have certain graphical tools that I'm trying to use, but the concept that you guys should follow is the same. I'm defining my terms as best as I can. I'm giving context for people who don't have detailed knowledge about the topic, and I'm talking about my thesis, what I'm trying to be doing, and I'm also trying to kind of make clear that my research is new and it's trying to answer a question that hasn't been answered prior. So a lot of what my research did was analyze assessment tools. A lot in clinical psychology, a lot of what our work comes down to is the validity and kind of the efficacy, kind of how good a tool is at assessing things like depression, assessing things like quality of life, assessing various fears, various anxieties. Without making sure that these tools are effective, it's tough to be confident in a diagnosis because these surveys and these questionnaires are our main weapons to kind of find out what a patient has or is suffering from. So a lot of what I was trying to do is assess the validity and kind of how well these tools are in the context of this particular disease. So again, this is all kind of introductory stuff, so I'll skip straight to kind of the first paper. So in this paper, I was talking more about kind of just the general socio-demographics of my cohort sample. And so I'll kind of skip through this as well. But I guess it would be interesting to just kind of for you guys to see the methods here. So here I was particularly interested in articulating, like, where is the cohort from, right? Why did I exclude certain people from being studied, and why did I include certain people? Why did I not want patients who had a life expectancy of less than a year? Why did I not want, if they had acute serious complications, if they had insufficient knowledge of a language that I was interested in? So all these things, right? Like, why did I want certain kinds of patients, and why did I not want other kinds? And then after I did get, so in this particular study, I believe I got 279 patients, and about 215 completed the questionnaire. So this is kind of what the methods is. You're talking about your thought process when you were kind of coming up with the experiment itself, and what your thought process is when you're running it, and making clear that if other people were trying to follow the same process, kind of help them as best as you can go through that. And this is my results table. So again, we don't have to go into exactly what all this means. These are all various statistical analyses. But the point is that basically this is my entire results, right? Everything that I want to talk about is on this table. I also briefly talk about kind of what some points are, but these three paragraphs are my entire results section. So as I said, results and methods are quite often easy to talk about, and it's quite a short portion of the paper. It's going to be the discussion that really is the key part here. Yeah, so in the discussion, again, I'm talking about kind of the gap that this study is trying to fill. I'm talking about why I was going after certain variables and not others, and I'm talking about kind of the interpretations of what my results showed me. There was an interesting point in the study where initially we believed that fear of progression of one particular variable that I was studying would be highly correlated with another, with depression. But my team and I were kind of shocked by how high the correlation is. So we didn't expect a high level of correlation here. So we talked about that in the discussion. The discussion session ideally should be a very honest place where you're talking about what you were surprised by, and what you were wrong in, what you were right in. So a lot of it is just going through your thought process, right? And trying to explain to people what the consequences of your results are. Yeah, so we can go through some of the other stuff at a later point in more detail, but I would say that this kind of summarizes a lot of what I was trying to say about the structure. Just to go back through it again really quick. You have the introduction, you're identifying the problem, you're going into the thesis and the hypothesis, and you're establishing a context. You have the methods, how was the research itself conducted. You have the results, you're summarizing the outcome in a table or just in a short paragraph or two, and then you're discussing it. What are the consequences of the data? What is future or research that can be done, et cetera, et cetera. So now we're going to be going into an assignment for this class that is a little bit more involved. What I want you to do is actually find an academic paper. It can be a very easy, very short, very simple paper, but I want you to find a paper that was published in a journal. And I list a website here that you guys can use for free scientific articles, but you can use any source that you'd like. I often use a site called Google Scholar that also has a collection of free papers. But I want you to read through the article, and then I want you to summarize very, very briefly, just with a line or two, like how we did with the previous question. And I would like you to go through each of the sections that I articulated here: the introduction, the methods, the results, the discussion, and talk briefly about how each section was kind of used to answer the underlying question of the paper. And also, ideally, I would like you to pick a paper that's in your field of interest that kind of relates to what you think you might do a future research paper about. So that's another point that I would like you guys to start thinking about now, which is in the coming weeks, and we're going to be starting to really key into what your specific thesis is. Like, what are you trying to answer? Like, what's the question that you're trying to look into? So start thinking about it now. This is an opportunity to start to wonder, what can I do my research into? And so one way to kind of get more information on that is to go through other people's work in a similar field. So so if you're interested in economics of finance, then look into a finance paper in a topic that interests you, and go through these steps. And also, of course, note the reference. And I think this will really help you guys with just reading a paper helps figure out how other people structure their papers, and helps you structure your own. Okay, do you guys have any questions about the assignment or about anything that I talked about today? Also, if everyone could message me their mails, their emails in the chat, that would also be very helpful for me to send you guys the first 2 slides. And if you guys don't have any further questions, that's going to be it. Excellent. Okay, thank you. So please send me your email addresses, and I look forward to talking with you guys next week. As I said, please actually do this. Assignment will not take a long time, and you don't have to summarize each section in a lot of words. A line or two is enough. I just want to make sure that you guys really know what the structure is before we move on into more specific things. Okay, so Shantanu asked how to structure for a research paper on a topic in mathematics or theoretical physics. So for more theoretical concepts like this, it's oftentimes similar. It's just what's the emphasis on. So how long each section is or how relevant each section is changes based on what the focus of the subject that you're studying is. Um, so, for example, if you're studying a topic that is not doing a lot of strict, experiments, like they're not in the real world turning over test tubes, then maybe your methods is not going to be super intricate, right? Because you don't have a strict methodology, but still you're going to have a process that you have to articulate here. Probably you're going to be more just jumping straight into the discussion. Maybe you don't have a results section per se, right? You have a question that you're trying to answer, and then you're jumping straight into kind of your thought process on how you answer it. And perhaps that's a good point. Next week, I'll bring a sample of a paper to go through at the end of the class, where we go through a more theoretical paper, a paper of a different kind, where you're not doing a literal experiment. So thank you for pointing that out. And next week we'll definitely run through that. But the point again, just like kind of how I talked with the hypothesis, the hypothesis is a theoretical tool. The structure is also a theoretical tool, right? It's to serve you and to serve other people and to help figure out a way to best articulate what you're talking about. But if you determine that for whatever reason in your paper you don't need a section, or or a section can be very short, or it has to be much longer, that's up to you. Okay, if that's, I'm going to be sticking around for a little bit longer. So if you guys have any questions, let me know. But other than that, thank you so much for sticking with the class. And I look forward to talking with you guys the next